All right, everybody, welcome back to our next lesson on quadratic functions. So today we are going to be learning how to use your calculator to graph functions and then solve functions from that and get a bunch of information from it. So I'm going to be demonstrating here on this virtual TI-83. If you have any version of a Texas Instruments, it will be really similar, although a few features might be different, but overall it'll be quite similar. So the basic idea is if we want to put a function, we can enter functions into our calculator here. Just make sure mine's turned on. And you can enter functions by doing so on the Y equals screen. So you can see in the top left corner here, this is that Y equals screen. When I press that button, it brings up this menu here, which looks similar to this. If I want to enter a function, I can do so directly into that. And I'm going to enter this function right here and this one right here. So y equals negative 2x squared plus 5x. So this is going to be put into negative 2x squared plus 5x minus 4. So that's what I'm going to enter. When I do that, I can just do that with the negative sign is going to be this one here, not the minus sign. They're actually a little bit different. So if it's just a negative, negative 2. And then for x, I'm not going to use the alphabet. The alphabet is a different function. I'm going to use this right here. This button here is going to choose basically a variable. So it's just going to put in an x for me. So negative 2x. To make a squared, I can just use this x squared. So negative 2x squared plus, and then 5x, and then last but not least, minus 4. And in this case, I can use the minus sign. Okay. Once I've done that, I can press the graph button to see what this looks like. Okay, so it's going to think for a little bit, and then eventually it's going to kind of spit this out right here. Now, whenever you solve any sort of problem using your graphing calculator, and it is a totally viable way of doing this, and often makes things much easier, you need to give me a certain amount of information. So the first thing we're going to do is we're just going to create a little sketch, just make a little picture, so that I know what you're seeing. And so I can see here that it crosses the y-axis somewhere down around there. And then the vertex doesn't seem to quite reach the y-axis before the x-axis before going back down. So it's something sort of like this, up and down along those lines. The next thing I need to tell you when I show you this picture is I need to tell you what the window is. So you can see that there's a scale here, and we'll see that we can change that scale. If I click on the window button, which is right there, it tells me what the values are. So it's basically telling me that I'm going from negative 10 here to positive 10. And we can see that on the x min and x max. And then the y min, it goes from, again, 10, positive 10, down to negative 10. And the way we're going to show that is down here in these boxes, we're just going to say in the x direction we go from negative 10 to 10, and then the y direction we go from negative 10 to 10, so that I know what the scale is. Obviously, if you change the scale, the picture is going to look a little bit different. So sometimes you need to adjust the viewing window. Sometimes when you graph it, when you look at your graph, it's not in the frame, or maybe it's too zoomed in or too zoomed out. So we can change that window, again, from the same screen. So for example, maybe I'll choose negative 20 for my x maximum, and then I'll leave my x maximum the same. So negative 20 for my x minimum. Or maybe I'll change my x maximum to 20 as well. And then I'll change my y minimum down to negative 20, but I might leave my y maximum the same. And so that when I hit graph, you can see I've kind of expanded out on the side, and I've shifted down a little bit. And so this is what the graph looks like with that new window. Okay. So again, as long as you can see the parabola or the function in your window, then that window should work. Okay, so now there's ways to analyze these graphs to get information from it, to get it from your graphing calculator. So you might want to find the vertex or the X or Y intercepts or whatever. And so we can do that with the following things. So that all happens here in the Calc menu. So Calc is this, it's just in yellow at the top there. And so it's the trace button, but to get to the Calc menu, I need to go second function. So second function and then trace, which will bring up the Calc menu. So you can see here there's a bunch of things I can do. I can look for a value, I can look for a 0, like for a min or max, intersect, and then it gets into fancy calculus after that, which you can worry about next year. So when I want to find certain things, so like for example here, let's say I'm going to do this function. So I'm going to enter a new function. I'll just clear that. And so I want to do y is equal to x squared minus 5x and then plus 4. So there's my new function. And I'm just going to take a look at my graph. Yeah, that's not a great window, so maybe I'll go back to the way it used to be and just put it to negative 10 and positive 10. And then I'll change this one to negative 10, and I'll take a look, see. And yeah, that's a pretty good window. So again, I just plotted here, I plotted y equals x squared minus 5x plus 4. So you have to state what you graphed, what your function was. And then I can see my graph here, it kind of crosses the y-intercept there, and then crosses the x-axis in two places. So something sort of like this. And then away we go. And again, remember that I changed my window here, so it went from negative 10 to 10 and from negative 10 to 10. So I'm just going to say, look, here's my window, negative 10 to 10, negative 10 to 10. And so here's a list of the different ways of finding different things. If you want to find the X-Intercept, we're going to do that through that second function trace, that's the Calc menu. So to find X-Intercepts, we're actually going to use the 0 function. So that 0 will help us find X-Intercepts. To find the Y-Intercepts, we're going to use the value function. So that'll help us find the Y-Intercept. And one of the ways we'll do that is we know that when the Y-Intercept occurs, when the X value is 0. So we'll just input a value of 0. We'll do an example in a second. To find the coordinates of the vertex, we're going to use either minimum or maximum. So remember, every parabola has either a minimum value if it's upright or a maximum value if it's inverted. So that's this minimum and maximum. And then, of course, if you have to find the equation of symmetry, well, that's just going to be the x value for the vertex. Okay, so let's take a look at this one right here. So we'll do a full solution and see what we get. So in my graph, I'm going to go back to this Y menu. I'm just going to clear this out, and I'm going to graph this here. So negative x squared minus 2x plus 5. Okay, and I'm just going to write here, I'm going to state the function that I graphed. So I put negative x squared minus 2x plus 5. That way anyone who comes and looks at this knows what function they're even looking at. When I hit the graph button, take a look. Okay, I can clearly see the vertex, I can see the X-intercept, so that's a pretty good window. I don't need to change that at all. So I can see that it goes something sort of like, I've got my axes there and there, right in the middle. I went from negative 10 to 10, and negative 10 to 10. And I can see it kind of goes, hits the x-axis, looks like around, I don't know if that's about 3.5, and then somewhere over here. So it's going to look something sort of like that. Okay. And now I need to find this information. So I want to find the vertex, and I want to find the y-intercept, and I want to find the x-intercepts, and there's 2 of those. So to find the vertex, I'm going to go to that calc menu right here. So second function trace brings up calc. To find the vertex, remember to find the vertex we had to use the minimum maximum value. Well, this has a maximum right at the vertex. And so I'm just going to go down to maximum. And when I hit enter, you can see that this little cursor has appeared on my graph. Now I can actually move that little cursor left and right. And you can actually see that it's actually asking a question. And the question is asking left bound. And what it wants to know is the cursor to the left of what you're looking for? See, this parabola goes on forever. And if you tell the calculator to start looking for the maximum value, since the function goes on forever, it would have to look forever before it would know if it found it or not. So what we're actually finding is a local maximum. We're saying, look, from here to here, find me the maximum in this range. We know, because it's a parabola, that if it's a maximum in this range, then it's the maximum for the whole function. So I'm going to move my cursor so it's definitely to the left of that, and I'm going to hit enter. So is it left? Yes, it is. And then it's going to say, okay, right bound. So I'm going to now move the cursor over so I'm definitely to the right of the vertex. And it doesn't matter how far you go, as long as you're definitely to the right. And I'm going to hit enter. And it's going to ask me to guess. And I don't know what that means, but I'm just going to say yes. And it's going to think for a second. And then it's going to spit out a value right here. And it says the maximum is going to happen at x. equal to minus 1.000001 and y equal to 6. Now, I will point out that the way the computer does this calculation is it's somewhat imprecise. So when it says 1.000001, it really is okay to just call that 1. It's okay to round that off to a reasonable number of sig figs. So the vertex happens at -1, 6. So that's my location of the vertex. For the Y-intercept, I'm going to go back to this Calc menu, so second function trace, and to find the Y-intercept, I need to use the value function. So if I hit enter when my cursor here is on value, I hit enter, it's going to say x equals what? And basically the Y-intercept happens right here when x equals 0. So you can put any value for x you want and it'll spit out the y value. But for the Y-intercept, that's where x equals 0. And so it's going to spit out for me, well, that happens at 5. In fairness, now that I've done this, I realize that I didn't really need a calculator for that anyways, because I could have just looked here and seen this 5, but I've done it and it happened, so there you go. So that happens at y equals to 5. All right, last but not least, the X-Intercept. So there are two of them, okay? I've got one over here and one over there. And so I'm gonna go back to my Calc menu, second function trace, and to find the X-Intercepts, I need to use this 0 function. The zeros of a function is just another term for where it crosses the x-axis, basically where the function returns a value of 0. And so if I hit enter, now there are two X-Intercepts, so I have to do them one at a time. I'm going to do the one on the left first. So I'm going to move this cursor, and again it's asking me, is it left bound? So I need to basically give it a range to work with where I know that the intercept is contained within that. So I'm going to move it over to the left and say enter, yes. And you can see it leaves a little cursor there, so I know I've chosen that. And now it says, okay, give me a right bound. So I move it so it's definitely to the right, and then hit enter. Yes, sure, why not? And I hit enter, and it returns a value here of, okay, the 0 happens at x equal to -3.449. Now again, I'm just going to round that off to a reasonable number of sig figs. So one of my X-intercepts happens at x equal to -3.45. Now I'm not done because I've got another X-intercept value, so I'm just going to go here, go to 0, and now I'm going to repeat the process by moving this over. And I'm going to look at that second X-intercept. So am I to the left? Yes. Move over a bit more. Am I to the right? Yes, I am. Do I want to guess? Sure, why not? And I return a value here of, I see 1.45 approximately. So x equals that, and it equals 1.45. And those are my two X-intercepts. Okay, so it's fairly straightforward, and with a bit of practice you will get it. I'm going to skip this next example and I'm just going to jump to how we might use this to solve other problems. Okay, so let's look at this example. We've got a rock thrown off a cliff, and the height in meters with respect to time in seconds is defined by the quadratic function h of t is equal to -4.9 t squared plus 12t plus 16. You may have seen in physics classes that as something flies through the air, it has a quadratic relationship with the height as it falls. So I'm going to plot that function here in my calculator. That function h of t, I'm going to plot it as y equal to -4.9 x squared plus 12x plus 16. Now, when I put that into my calculator, it doesn't matter, -4.9, it doesn't matter that I use t or x or anything, so I'm just going to use the x variable. I know that corresponds to the time in this case. So -4.9 x squared plus 12x plus 16. And let's see what this looks like. So when I hit graph, it's going to return a value that looks like this. And I can sort of see what's going on, but it's hard for me to see the entire graph, and I'd really like to. So I can see that I'm fine in the x direction. That doesn't matter. I don't need to see any further in the y direction, but I just need to scale and move this up a bit. So I'm just going to change the window so that my y max, I'm going to go up to, I don't know, 20. And I'm going to hit graph and see what I get. And you can see that I'm closer, but I'm just not quite there. So maybe I'll move the window up to 30 and see what I get. And I get, okay, so now I can see the full scale of the parabola. So I'm going to sketch this out really quickly here. And so I did shift this down. I didn't do anything in the x direction, but I shifted it down. And it looks like I've got a y-intercept up here. and then it kind of goes up a bit and then comes back down. So, and the X window is going to be from -10 to 10, and the Y window is going to be from -10 to 30. Okay, so I'm going to use this graph to answer a bunch of the questions here, like what is the maximum height, when does it reach that height, and so on. And I'm going to do that using the same tricks I just used from before. So the maximum height, well, the maximum value for this function, h of t, is going to happen at the vertex. And so if I find the location of the vertex, then that's going to give me a bunch of information. So let's do that. I'm going to go second function trace, and I'm going to find, in this case, a maximum value because that's the peak. So hit enter. I'm going to go left bound and hit OK, and then I'm going to go to the right, and I'm going to hit again enter, and then I'm going to get it to guess. And it's going to spit out a value. The maximum, the vertex looks like it happens at 1.22 and 23.35. So the vertex happens right here at 1.22 and 23.35. Okay, so what does that tell me? Well, h of t is the function which represents height. So the highest that this rock goes is the y value at that maximum. So the height here, the maximum height, is going to be 23.35 meters. And when does it reach that height? Well, it reaches the height when at the vertex, and the time that happens is the x-coordinate of the vertex, so that happens at the 1.22 second mark. Now, how long does it take to reach the ground? What does this all mean? The rock was thrown here at time equal to 0. So the rock was thrown here at time equal to 0, it goes through the air, and then when the height is 0, then it's hit the ground. Well, the height hits 0 when this crosses the x-axis. So it's basically asking, what is this x-intercept? So if I go back to my graph here and go to my Calc menu, and I find a 0, I'm going to navigate over to this 0 over here, and I'm going to do the left bound and then the right bound, and hit enter, and it returns a 0 of 3.40, let's say. So 3.40 seconds is when that's going to hit the ground. Now, how high is the cliff? Remember, this was a student standing on a cliff throwing the rock in the air. The starting point would then represent the height of the cliff. So the starting point here is the height of the cliff. Now, I could go and punch this into my calculator, and I could figure out the y-intercept here, but I remember from last time that the y-intercept is just going to be this value. So that would just be 16 meters. And then the last is, what is the domain of this function? Well, this particular parabolas of course go on forever, but this refers to a specific event. This graph only really makes sense from time equal to 0 up until the time that the rock hits the ground. Obviously, there's no real negative time. The rock wasn't doing anything, and after it hits the ground, it's going to come to a stop. So the real domain here is not all numbers. We really can only use this function while the rock is in the air. So that would be from 0 being less than or equal to x, which is less than or equal to 3.40 seconds. And so that's the domain of that function. Okay, that's it for graphing calculators.